Metallic Bellows was founded in 1980 and is a leading broad-spectrum manufacturer of metallic bellows and related products in India. Metallic Bellows has always had a single focus: to manufacture a wide spectrum of expansion joints that help industry run more reliably, efficiently and economically. Metallic Bellows services customers from cost-competitive, high-volume industrial segment to custom-designed, unique applications for scientific or space applications. Working from a spacious manufacturing facility of 2,700 square meters, with an unending desire to honing its technical expertise and of course making the impossible possible, today Metallic Bellows is the primary choice of customers for products and services to improve reliability, productivity and performance in the process industries. To really understand the contribution of the company to the industry it serves, we need to understand the pressures and forces that work on the pipelines. When pipelines are subjected to hot or cold conditions, they expand or contract. This creates thermal stress, which is injurious to the various supports in the pipeline. When a length of steel pipe fixed at both ends is heated uniformly through 200 degrees centigrade, a stress of approximately 4.6 tons per square centimeter is end-generated. This force will act upon the supports of the piping system. If the supports are not strong, the piping systems may collapse, resulting in serious damage to man and equipment. Modern expansion joints, when compared to conventional piping system, have effective applications under specific conditions. An expansion joint consists of a flexible unit called bellows with necessary ancillary hardware like pipes and flanges. Expansion joints are capable of axial, angular and lateral movements. They are not capable of torsion. The design of a bellows is complex, as it involves an evaluation of pressure capacity, stress due to deflection, fatigue life, spring forces and instability or squirm. The determination of an acceptable design is further complicated by the numerous variables involved, such as diameter, material thickness, pitch height, number of ply, method of reinforcement, manufacturing technique, material type and heat treatment. In many cases, the design for a particular application will involve a compromise of conflicting requirements. Computerized analysis techniques have been applied to more accurately consider the effect of thickness and shape variations as well as plasticity. The procedures are obviously more complex than a simple elastic analysis, and yet do not fully solve the design problem in the absence of experimental verification. Application complexities have resulted in a wide range of bellows. To sum up, the variables in design are cycle life, diameter, dimensional limitation, flow loss, height, heat treatment, hardware, pitch and stress calculations. Once we have understood the primary design complexity of bellows, we also need to know that bellows are the primary component of an expansion joint. The other components are collar, control rods, cover, equalizing rings, flange end, hollow reinforcing rings, limit rods, liners, motion indicators, pantographic linkages, purging connections, shipping bars, solid root rings, tie rods and weld end. Addition of a combination of these components to the expansion joint will result in a product of increasing complexity and capability that can be used in a wide range of applications. Expansion joints are of various types, each meant to operate under a specific set of design conditions and for various applications. The most basic types of expansion joints are double expansion joint, externally pressurized expansion joint, gimbal expansion joint, hinged expansion joint, jacketed expansion joint, inline pressure balanced expansion joint, internally guided expansion joint, pressure balanced expansion joint, single expansion joint, swing expansion joint, universal expansion joint, universal tied expansion joint. Since the expansion joints are meant to serve a critical range of applications, quality control and quality assurances are of utmost priority. To ensure that all products adhere to the required specifications, Metallic Bellows follows the following test procedures. Cycle life test at room temperature and design temperature, squirm test, spring rate test, pressure test, helium leak test, radiography test, mechanical test, chemical test. Spring rate. Law of forming is thinning. Instead of thinning 5%, if we form with 10% thinning, the spring rate ratio will become 1:2. If the pitch varies plus or minus 2 mm and height plus or minus 2 mm, the spring rate will vary from 1:4. Because of these factors calculated, spring rate will vary with actual spring rate by 100%. Manufacture of bellows is considered as sheet metal work and is not a CNC operation. There are 4 established methods of forming bellows: roll forming, expander mandrel forming, hydro forming, and press brake forming. Circular bellows are formed by the first 3 systems. Bellows formed by hydro forming and expander mandrel need to be sized using the roll forming method. The convolutions of the bellows are formed by a violent operation. During the operation, the sheet metal is drawn equally from either side. Further, the operation will cause thinning of the metal either at the crest and root area or occasionally in the center of the convolutions. Bellows formed in this type of operation will not necessarily have a uniform spring brake. It is to be noted that bellows made by forming will not be symmetry axis, equal distance in the pitch, equal height, will not be squared at the base. The ends of the bellows will not be parallel. What is important is that the bellows must meet critical parameters like pressure, movement, cycle life, etc. Metallic Bellows follows the following national and international standards in the manufacture of expansion joints. In addition, the company is constantly upgrading its facilities to match evolving standards. The final testimony to the company's drive to meet challenging requirements is the exhaustive list of customers who place total confidence in the products supplied by Metallic Bellows. Today, Metallic Bellows is proud of its past, excited about its future, and confident of being able to meet the challenges that come its way every day.